Hello everyone, and welcome to part 2 of the Grade 8 Advanced Mathematical Term 3 curriculum structure. In this part, we will continue with lessons 11 to 20. Learn new mathematical ideas and solve practice questions. Let's get started with lesson 11. Today's lesson is on similar figures and sequences of transformation. Two figures are similar if they have the same shape. They don't have to be the same size, but they must meet in two conditions. Corresponding angles must be congruent, which is equal. Corresponding sides must be proportional. And to determine if two figures are similar, we use a sequence of transformation: translation, reflection, rotation, and dilation. The formula for the scale factor is K equal image length divided by original length. And to check for similarity, simply compare the angles, check if the sides are proportional, then calculate the scale factor and identify the transformation used to map one figure into another. In this lesson, we're moving from identifying similar polygons to actually solving for missing measure. To confirm that two polygons are similar, they must pass two tests. All corresponding angles must be congruent, exactly the same. All corresponding sides must be proportional. If they pass, we use the scale factor K to find the missing side's length. The formula is K equals image length divided by original length. To solve for a missing side, follow these four steps. Match the corresponding angles and sides between the two figures. Calculate the scale factor using the sides you already know. Set up a proportion using that ratio to find the missing side length. Finally, write the similarity statement to show the relationship between the two polygons. You need to remember, if the scale factor is bigger than 1, the image is larger. If the scale factor equals to 1, they are congruent, the same size. If it is smaller than 1, the image is smaller. For this problem, we need to determine which statements about triangle ABC and XYZ are true. First, I will compare the side lengths of the two triangles. In triangle ABC, the side lengths are 6, 7, 7. And in triangle XYZ, we have 3, 3.5, and 3.5. So now we will check the ratios of the corresponding sides. So 6 divided by 3 equals 2, and 7 divided by 3.5 equals also 2, and 7 divided by 3.5 equals 2. So since all corresponding sides have the same ratio, the triangles are similar. However, the triangles are not congruent because their side lengths are not equal. One triangle is a scaled version of the other. Therefore, the correct answers are the triangles are similar, and ABC is similar to triangle XYZ, which is this one. This is the correct answer. And now we're learning about the volume of a cylinder. Volume tells us how much space is inside a three-dimensional object. And to find the volume of a cylinder, we use this formula. V equals pi r square h. Here, V stands for volume, R stands for radius, and h stands for height. The first thing we do is identifying the radius and the height. Next, we square the radius and then multiply by the height. One important thing to remember is that if we are given the diameter, we need to divide it by 2 to find the radius. And don't forget, volume is always written in cubic unit, like cubic centimeter, cubic inch. And once you follow these steps, finding the volume of a cylinder becomes quickly and easy. So here we have a cylinder. So volume equals by r square h. So here we have V equals by the r, the radius is 7 multiplied by 7 multiplied by 20. So 7 multiplied by 7 is 64 multiplied by 20. So 64 multiplied by 20. So 0 and 0. 2, 8, 12. So 1, 2, 8, 0 by. So now we will multiply by 3.14. So 3.14 multiplied by 1280. So 3.14 multiplied by 1280 is 4019.2. So this is the answer, centimeter cubic. So now we have the volume of a cone. So the formula of the cone, volume of the cone, is V equals 1/3 by r square h. So now let's go to the question. So now we have the radius is equal to 90 centimeter and the height is 35 centimeter. So we're going to go to do V equals 1/3 by r is 90 multiplied by 90 multiplied by 35. So 90 multiplied by 90 is 81 0 0 multiplied by 35 is equal to 283,500. And then we will divide it by 3. Nine, 4, 5, 0, 0. And then we multiply. We don't need to multiply by 3.14 because it is given by. So 9, 4, 5, 0, 0. So the volume of a hemisphere. The only thing you need to know in this lesson, the formula of the volume of the hemisphere is V equals 2 over 3 by R cube. Here we don't have a height because the hemisphere doesn't have a height, and the radius we will multiply it by cubic, not by square, not 2 times, 3 times. So let's go to the question. So we have a hemisphere here. So the formula is V equals 2 over 3 by by R cube. So now we have the radius, which is 6.7. So V equals 2 over 3 by 6.7 multiplied by 6.7 multiplied by 6.7 is 300.763. And now we will multiply it by 2. So 300.763 multiplied by 2 and then divided by 3 is 200.50866. So 200, no, and then we will multiply it by 3.15 or 14, sorry. So the answer will be 629,597. No, sorry. It will be 629.6. So this is the answer. Don't forget to put feet cube. And now we have the volume of a sphere. So volume of a sphere equals V equals 4 over 3 by R cube. So now we have the diameter. So we will divide 18 divided by 2 will be 9. So 9 multiplied by 9 equals 729 by 4 over 3. Okay. And then we will multiply 729 multiplied by 4 divided by 3. It will be 972, and then we will multiply it by which is 3.14. It is the radius is 9, the volume is 3052.08, and when we round it to the nearest tenth, it will be 3052.1. Lesson 19, Scatter plots and association. We will learn scatter plots. A scatter plot is a graph that shows the link between two things. And to make it, first we write x on the bottom line. This is independent variable. Then we write y on the signed line. This is dependent variable. Next, we choose simple numbers for the scale. After that, we put each point on the graph. In the end, we give the graph a title. Now we look at the pattern. If the points go up, it is positive. If the points go down, it is negative. If they make a straight line, it is a linear. If they are curved, it is nonlinear. Sometimes there are strained points that do not fit. We call them outliers. Scatter plots help us see data clearly. Now we will not just learn, we're detecting patterns like data detectors. Imagine you have a scatter plot. It is just a graph that shows how two things are connected. First mission is to build the scatter plot. We start with the axis. X-axis on the bottom, which is independent variable, y-axis on the side, dependent variable. Then we choose a simple scale, nice and easy numbers. Now the fun part. We plot each point one by one, like dropping stars in the sky. And our graph is alive. Now, what does it tell us? We don't look at single points. No, we look at the big picture. What is the trend? Going up, positive association. Going down, negative association. Straight line, linear. Curve, nonlinear. But wait, what are those weird points? Those are outliers. They do not follow the pattern. They stand out like that one student who didn't get the meme. Always focus on the overall trend, not just one dot. If you're given a diameter, don't panic. Just divide it by 2 and that will be your radius. Scatter plots help us see stories in data, and now you can read those stories like a pro. That's it, you did it. We're stepping into something super powerful in data. We're learning how to predict the future using a graph. First, what is a line of a best fit? Imagine a scatter plot full of points. The line of best fit is like a leader line. It goes through the middle of the data and shows the overall direction. It helps us see the trend and even make predictions. Let's go step by step like detectives. Look at the scatter plot and draw a straight line that goes through the middle of the point. Try to balance the data above and below the line, and then choose 2 points that are on the line or close to it, and make sure they are easy to read from the graph. Now we calculate how steep the line is. We need to find the slope. The slope equals change in y divided by change in x, and that tells us how fast the data is increasing or decreasing. Now we will find the equation. We will use the form y equals mx plus b. M is the slope, b is where the line crosses the y-axis. Put everything together and you will get to your line of best fit equation. Once you have the equation, we can plug in any x value to predict y. That means we can estimate unknown data using our line. What is a two-way table? It is a table that shows how two things are connected, like study time and grades, boys and girls, and sport choices, yes or no answers in groups. It helps us compare groups clearly. Now, what is relative frequency? Instead of just counting numbers, we convert them into percentage or proportions, so we can understand data better and compare fairly. Step 1. Draw the table. One category at a row and the other category at columns. And then we need to fill the data and find the total and convert the relative frequency. Part divided by total will give us a decimal or percentage. And then we will fill the table again, replace or add the relative frequencies into the table, and it shows proportions, not just counts. So you just learned how to turn raw data into powerful compressions. We finished part 2 of grade 8 advanced mathematical curriculum. From scatter plots to line to best fit to two-way tables. We learned how to read data, find patterns, and even make predictions. It wasn't just math, it was learning how to understand the world through data. Thank you for watching, and bye.